All right, everyone. Thank you for joining me on this talk. We're going to talk about how to navigate the complexities of stateful workload on Kubernetes. All right, let's get right into it. So imagine an admin having deployed a Kubernetes cluster, which is, everything is running smooth, it's on autopilot, it's relaxing. Right? We all know what happens when someone is relaxing. Mr. Murphy is going to get to him. Through a new kind of workload. Can anyone guess what has changed? All right, we'll find out. All right. So having navigated in this cloud-native waters for a long time on autopilot, our admin suddenly finds out something has changed. Some new kind of workload that was thrown at him causes his ship not to sail smooth anymore. So he wanted to find out what went wrong or what has changed. He digs in and then finds out new kinds of things that he had not heard before or he didn't have to worry about, like data persistence and data security, high availability and scalability and so on. Can anyone guess what has changed now? All right, it was the Postgres database, right? So he was running all stateless workload, and then now that somebody threw a Postgres workload, which is a stateful workload, which has data has gravity, and it creates a drag. And he has to think about a lot of new things that he had not thought about before, right? Having understood that there is data, there is stateful workload right now, the admin has to make a decision. He clearly understands that he cannot rely on local volumes anymore. He needs to think about something enterprise grade because we are dealing with data. So he's left with choices. He needs to make a decision. One is toss out Postgres database and then move on his cloud-native journey with stateless workload, or make the right decision. Find out a software-defined storage that can help him run enterprise workload. Right? All right, so why do we need a software-defined storage for running stateful workload? So Kubernetes, by design, from the ground up, built for compute-heavy workload, which are pretty much stateless. And again, by design, the storage management is kept outside Kubernetes, and the storage vendors can interface with Kubernetes through CSI. So there are a lot of storage vendors out there, right? Now, having understood that he need to find a software-defined storage, what are some of the technical considerations our admin can, has to do in order to find the right software-defined storage? So we'll get right into it. We'll talk about like few of these technical considerations. Right? Number one, data persistency. Why? See, when you're running stateful workload, you're actually dealing with mission-critical data from your enterprise. And now, most of the workloads right now, right, there are new kinds of workload that are running at the edge, right? It could be on retail stores or mining or ports. They don't have the luxury of using the cloud because there is latency, there is egress cost, so they have to do local data processing. When you're doing local data processing, you have to think about how do you secure your data? How do you protect your data in the case of failure? Because if a node goes down or a disk goes down, Kubernetes will relocate the pod to an available server. But what happens to your data? If your data is not replicated, it's not protected, right? And now, because you're not in the cloud, you have to deal with all of those things. That's where software-defined storage comes in. So data persistency becomes a key. What else do you have to look for, right, when you're looking for a software-defined storage? Is it versatile? Can it run all kinds of stateful workload, or is it purpose-built? Can it support containers as well as VMs, right? And the next is scalability and flexibility, right? The system needs to be, scalable. It should support smaller deployment and then scale all the way, up to hundreds of nodes, right? And then it should support multiple data access modes rewrite many RWX. Most of the AI/ML workload requires RWX, and then also support for block, file, and object. Right? If you find a software SDS that supports all of this, you pretty much cover all kinds of workload, starting from a small cluster to a large cluster. So this is an important consideration. The next is high availability of the system itself. In the first requirement, we saw that data high availability. Right now, we are looking at the high availability of the control plane of the software-defined storage. If a node goes down, or more than one node goes down, can the management plane of the software-defined storage handle that? Right? That's another important consideration. And then, does it have strictly consistent replication, which is actually required if there is if you are replicating the data, and then can it resync if there is if any replication is falling behind, and then how does the fast failover happens if there is any problem, right? And then the next important consideration is performance. And see, because we are involving a software layer, there is going to be a tax, but how big is the tax? Right? Is it like 30, 40%, or like is it close to bare metal where you can handle that? And then the important things that you have to look at here is, does it support data balancing? Does it support quality of service? Things like that. Right? And the next important thing is data management. So you are on-prem, deployed different kinds of workload. Again, we are dealing with data. Usually, data goes through a life cycle, right? Does it support snapshot, clone, rollback, and then is there a backup restore functionality available within the system? And how does it do all of those things? Is it like incremental, or does it like create I/O bottlenecks when you do all of those things, right? How is the backup supported? Is it like a backup built natively, or do you have to, again, get another license for getting a backup, or do you always have to use a third-party backup? These are some of the considerations that you have to look at, right? The snapshots and clone protect the data in case of I/O or user errors, but these are usually kept in the cluster. Backup is when you're actually backing up to a remote location, so that can protect your cluster and data from disasters, right? And then obviously security is an important thing. You need data security in the form of encryption, and then how easy it is to manage the storage, right? It should work in similar to Kubernetes ethos with declarative syntax, and then it should be easy to provide capacity management and other stuff, right? And obviously the next one is how well it integrates with Kubernetes. Is it like built ground up, with Kubernetes for Kubernetes? Basically, is it cloud native, right? Or is it retrofitted from the olden days into the cloud native, right? That are some of the things that you have to look at. And obviously, cost management. If a system scales at the pace at which you're growing, as long as you're not planning for peak performance, you're actually managing your costs properly. And this is a typical or ideal deployment structure. So this shows the 6-node Kubernetes cluster where 3 of the nodes run the management plane of the software-defined storage. And then it pulls together all the hardware disks that are available. And then, when a pod is deployed, you can say, how do you want to protect your data? Here is an important consideration, right? You don't want to pick a system that enforces cluster-wide policy by default for all kinds of workload, because what is right for Postgres may not be right for MongoDB or Cassandra, because they are all distributed systems. They protect their own data differently, right? So now you should find a system that provides the flexibility of choosing your replication based on your workload. You don't want to replicate distributed databases like MongoDB or Cassandra, which is already replicated 2 or 3 times. You don't want to add additional storage thing, right? So you need to have that kind of flexibility that's going to help you. All right, in conclusion, when you're running a data workload, you need to look at different things that are normally looked at for a stateless workload. This includes data availability, data protection, security, and other stuff, right? that concludes my talk, and thank you all for listening to the talk. We are at booth S763. Come say hi tomorrow if you can. Thank you so much.